Hello, good evening, everybody. Hello, good evening, uh, Fukuile, Steven, Adam, Nana, Tony. Hello, good evening. How are you guys? Let me know if you can hear me well. And welcome to the Power Live number 4. This means that this is the fourth time I am hosting this kind of special class that is specifically made about one topic. In general, I receive these topics by my students, by everybody who takes part in my complete course in the Career Boost with Power BI. And here we are tonight or today for you to talk about inventory. Today, we are going to talk about inventory analysis on Power BI. It's going to be really interesting, I promise. And also, we're going to go more advanced, okay? I can tell you that we are going to go more in depth into the data model subject, to the DAX language subject as well, as we want to create more refined projects with some uh, new types of visualization, and for that it requires some knowledge about data modeling first, and then DEX measures, DEX language second. Okay, so I will give you the introduction. I will talk about the business case that we have for this week and this class you're watching right now. Today is Tuesday, and I'm going to host two more sessions on that is going to be tomorrow and on Thursday as well. So we are going to have 3 days to develop this project. This is not going to be a very superficial one. Okay, we want to go more in depth, as I told you. So that's why I chose 3 days. Okay, so let's go for it. Let's go. And guys, we are on YouTube. This is live on YouTube. Okay, this means that I can read your comments here in the chat, and you are watching this live. So please, this time you need to pay attention to the class, to the steps that I'm doing, and take notes of this. Okay, and I totally recommend you to watch this from a computer, a tablet, or a smart TV. This means a device with big screen. Okay, I totally recommend you a big screen now. And be sure to watch this class live. The live signal is supposed to be read here in the YouTube player, and sometimes there is a little delay between what I'm saying and what you are watching. So please be sure to see the red live button here on YouTube. And also remember to set this the quality of this as high as you can. Okay, uh, prefer 1080 pixels, that is high definition. Okay, I am broadcasting this with a very good internet speed, so be sure to change your YouTube settings in your YouTube player. And guys, for now, what do you need for this class is only pay full attention. Okay, make yourself comfortable. I know that you have worked all day long. So grab a glass of water, avoid distractions, turn off the cell phone, grab a notebook to take note of the important parts, and make yourself comfortable. That's the important thing, okay? And first, you will watch me doing. All right, first pay full attention, because in a second time, later after the class, you can download the materials. I will leave the link here in the description of this video. The link is not available now. The link will be available after the class ends, okay? So you will have the opportunity to watch this class later again. So you will try to imitate what I'm doing. You will follow step by step, okay? And when is the time that you really learn Power BI for real? It's in the third time, because in the third time you will try by yourself without following the step by step, using your intuition, using your memory, and then you will do this by yourself, and that's when you really are going to find some details, and you will try to solve it, and that's when you really learn. Okay, so that's the process. Trust the process and come with me. Okay. Perfect. And guys, the materials available. As this is a very special class, I have to create a distinction here. Okay, I have here two categories. The first category, I know that I have many people from my complete course here watching this live class. So the people enrolled in the Career Boost with Power BI, you can download the databases. The link will be on Hotmart after the class. Okay, I will send this on Hotmart for you. And the databases will also be available for the free students. Yes, if you are a free student, you have just found my video here on YouTube, you can still download the databases as well to practice. You can also download the backgrounds, as we are going to create a very fancy dashboard. We are going to use a special background, an image. So you can download this being a free student as well. However, the PowerPoint file that is open for you to edit, for you to change, customize, is only available for the students enrolled in my complete course. Okay, if you are a free student, you will not receive the PowerPoint files for you to change. Just to give you one demonstration of what I'm talking about, this is the PowerPoint file where I have created the background. Okay, so if you are enrolled in the complete course, you can change, you can delete my logo, you can create new pages, change the boxes sizes and so on. Okay, so that's it. And what else? Also, if you are enrolled in the complete course, you can also download the Power BI file, okay? And then immediately use this into your own portfolio. You can download and use this in your portfolio. And everything here is going to be available on Hotmart. I will leave the link here later in the description of this video, and I will also share in the WhatsApp group, in our WhatsApp group. And well, if you are free students, enjoy the databases for you to practice and use the backgrounds for for learning as well. That's a very good opportunity. Okay, and of course, all of this is going to be available for a limited time on YouTube. And well, talking more about myself, I know that some of you still don't know me very well, but I am a Power BI consultant, and I have this background related to Lean Six Sigma and agility. Uh, Lean Six Sigma is a framework, a methodology for continuous improvement, okay, for improving processes. And I have been working for a few years with Power BI, for 4 or 5 years with Power BI, and uh, I have extensive experience with data analysis in general, especially supply chain and in continuous improvement overall. Okay, I have this background related to IT, mining, finance, not automotive, and nowadays I focus only on automotive clients. Okay, I still offer consulting services, and nowadays I just focus on automotive. Okay, very good. And guys, I am a Microsoft certified trainer and also a Power BI data analyst. I think I have other fellows Power BI data analysts here in the chat as well. So I believe you are in good hands to talk about this, okay? So just to summarize, I believe we may have a few beginners here. Just to summarize what we want to do on Power BI. What is the beauty of creating a project on Power BI? On Power BI, we can consolidate multiple data sources, right? You remember? So in this case that we have tonight, I will make things easier, okay, regarding the data sources, because we don't want to spend our most of our energy in the data sources here. We want to talk more about the analysis themselves, okay? And then we can consolidate all these data sources on Power BI Desktop. That is the software we are using here. And just to remind you, Power BI Desktop is free. You don't need to pay anything to download and install in your computer, okay? It's all free. And we are going to create this dashboard that later we publish this into the Power BI service that is in the cloud, okay? And then this will become available for other people to access this from their devices. This could be our boss, our client, and so on. Okay. So with this, we have an automated dashboard. Here, I'm talking about automated update. We have more time to analyze the data, deeper analysis, and we want to take better decisions. That's all we want to do. And I have created a framework to detail all these steps. Okay, if you are my student, you may know these steps, but I never get tired of showing this. I need to talk about this because we're going to talk about each of them here tonight. Okay. So the base of this, making an analogy with a house, right? We have the foundation of this house, and the foundation of our project here is the ETL, right? The first part when we extract, we transform, and we load this data into Power BI. In our case, it's going to be very simple for tonight. I don't want to make this complicated because we will focus on the data model and in the measures for this project, okay? That are the pillars. And then later, we are going to create the visualization, a very fancy visualization that we are going to spend more energy tomorrow and on Thursday, okay? We're going to spend more energy in the visualization tomorrow and on Thursday. So finally, we have the publishing part, that is the ceiling, that I'm not going to address here in this event this week. Okay, so that's the framework that I have created to teach Power BI. First, I created just this to sell projects, to sell Power BI projects to my clients. And then later, I started using this with my students as well. All right. And well, now let's get to work. We are done with the introductions. So we have this. Oh, let me change one thing here. 1 second. Perfect. So we have this inventory analysis for this company called Exodus Bikes, okay? And then we are going to have this file only, this dataset.xlsx. That's an Excel file that you can download after the class ends, okay? This is the file. So I'm going to show you the file in a minute, So hold on. But before starting here, from 0 to 10, how well are you with me? 10, you are totally on board. 10 or 0, like you have just started. Tell me here, let me have an idea of where we are. Okay, Basi 10, Chris a 10. Okay, perfect. Hello, Marcin. Okay, most of you are on the same page as me. Perfect. So let's start talking about this company overall to give you the context that we have here. Now, we have this company that is Exodus Bikes. The company background, it's a mid-sized bicycle manufacturer, and it's headquartered in Cape Town with a second warehouse in Durban. This means it's from South Africa. So they produce 8 distinct models, okay, and then here we have all the 8 models in the text, and stock around 200 unique parts. So we are talking about around 200 unique parts in our database. And these parts are like frame tubes, forks, wheels, drivetrains, brakes, and so on. Okay, all the parts from a bicycle. And let me tell you, Where did I get this data set? How? Well, I created, okay, this data set. You will not find this data set anywhere in the internet because I created this. For creating this class, I spent most of my time creating, refining the data. You trust me, it's very hard to find good data online. So I had to create this data by myself, okay? Of course, I used ChatGPT and Python to do that, and it's all created by me, okay? And I chose a bicycle company, a bicycle manufacturer, because bicycle, let's say, it's a common language for everybody. Everybody understands the parts and so on, okay? Doesn't matter the country you're from. And your area, of course. So we have a few problems with this company. You know, we have a very huge uh, stock uh, level, and you're going to see later when we open the data and start analyzing and summing all the numbers. But you are going to see that this is not optimized at all. Okay, it's not optimized at all. So we have a few concerns to begin with. Okay, so we need just to check first the current inventory health. Okay, this is going to be important just to have an overall idea of how things are going, if they are going uphill or downhill. We need to identify the drivers of excess or short stock. So we are going to analyze the stock levels. And we need to also propose some data-driven improvements to balance service levels. So we are going to check later how is the service level in comparison with the working capital. So we can have more ideas about this. And this is not something that is going to be 100% accurate, I think, the streamlined purchase and timing quantities, because I believe first we want to address the analysis of the current situation. Okay, you are going to see that we have a table with some purchase orders. Maybe we can create some analysis with this on Wednesday if we have time. Okay, but first we're going to focus on in the analysis of the current state. If we have more time on, I'm sorry, not on Wednesday, on Thursday, that is the third day. If we have more time on Thursday, we can proceed with this analysis. And well, we have a couple of questions and deliverables that our boss is asking for us. So the first thing that we need to check is uh, an overview, right? That we need to check the inventory level. This we are talking about money, monetary value, and also in units, okay, in parts in stock. So we need to calculate how much we have in stock, and also we need to validate the COGS, that is the cost of goods sold. I'm going to explain better what is this KPI. That is a very important KPI of inventory. And we are going to see the DIO, that is the days inventory outstanding. That is another very important KPI. And then we need to interpret the bike level turnover versus the inventory turnover. This is a very important subject because, as you are going to see, we may have a few parts that could be used in any bike, and we have different demands for each type of bike. So we are going to see how each type of bike is performing in sales, and also how this is going to reflect in the stock. Okay. And well, we have here many other analyses like the ABC analysis that is very famous. So if you are not from logistics or supply chain, you may have heard about Pareto principle. There's something that we are going to use here related to Pareto, okay, that is the ABC analysis. And in the ABC analysis, we're going to list all the parts that are most dominant in terms of value in stock, okay? So this means that we want to identify which parts are most valuable in stock, and maybe they weren't supposed to be as high as they are. Okay, so that's a very important KPI for inventory. And we're going to create this full visualization. It's going to be very interesting. Okay, and then later we are going to talk about the coverage and the DIO, the days inventory outstanding, and we want to address the turnover optimization as well. So we have many analyses here to create, and this is going to rely a lot on DAX. Okay, if you are not very familiar with DAX, I suppose it's better for you to go with easier examples, okay? Because here I tell you that this is going to be more advanced. And my focus in this class will not be explaining each function, okay? Because in my course, I already have one separate class explaining all these functions. So I totally recommend you to, if you don't know how one specific function works, you can go back to my other classes and see the specific explanation if you want to, okay? So here we want to focus more in the business case. Well, and yeah, as I told you, if we have more time on Thursday, we can address the purchase order alignment as well. And in the end, we want to end up with some strategic recommendations. Okay, we can summarize some quick wins based in the data analysis we will be able to perform, and uh, we have here some deliverables. Okay, we have some deliverables. So for example, we can identify the reduction of certain items, and we can estimate the amount that we can save and reinvest in the business itself. Okay, so we can end up with some interesting analysis like this that we are going to talk more about in the last day. If we achieve to do everything correctly, this will be possible. Okay, so yeah, guys, as you see, we have many different analyses waiting for us. So let's start. First, I will introduce you the database. This is the file you can download after the class. And for tonight, I will make available only the Excel file. Okay, I will make available only the Excel file for now. So let me see. Well, in this file, you will find in each spreadsheet here, in each sheet, is one table. Okay, so we have here all the tables, and they are already detailed as if they are a dimension or if they are a fact table. Okay, and for this class, I also expect that you may have some basic basic knowledge about the difference between dimension and fact tables. Okay, because we want to skip this in this class. So yeah, all the tables are here. The D calendar, you don't need to generate the D calendar. The D model is here. The D model parts. Oh, let me show you how many models we have. We have here seven models, okay? And then we have the D models parts. This table of D models parts is, like some of you may know, a bridge table, okay? As you can see here in the name, we have the D models that comes from the D model. And we have the other part that is parts that comes from the D parts. And what is this, Tarcísio? What is this? This means that this is a bridge table. You will understand better when I create the data model. So you will see visually the impact and the need of this table for us. Okay, for now, hold on, just trust me. And we have the D parts, that is the table where we have all the parts listed. Okay, so we have here 202 parts. Okay, 202 parts, and then you can see the parts codes that they have some patterns. So, for example, the BC001 is related to the model code BC001. Okay, when it starts with this, is related to this model. So we have this kind of pattern. However, we have some parts that are shared between the models. Okay, these parts are shared between the models. So the rims, the tires, the hubs, and so on, they can be shared with other models. And well, you can see that how we can identify which part belongs to each model. How we can identify the part that belongs to each model. The way we do to create this connection is using the models parts. Okay, here we have listed the model code and the part code, the part number that this uh, it will be correlated, will be linked. Okay, so and we also list here how many parts we have of this in each bicycle. Okay, so for example, if we see here the tires, usually we have two tires in a bicycle, right? Let me see. It's in the four. Yeah, tires and inner tubes. So yeah, we have here quantity per bike, we have two. Yeah, so the four, we have two. Exactly. Okay, so you find this explanation here. RB, do we get the test in the end of these classes? No. This week we don't have certificates. We if you are watching this, you are watching just for learning. Okay, you are a true learner. We don't have tests and we don't have certificates this week. Okay, and well, the D part, that's the table I have just explained, and we have the D supplier. In the D supplier, we have the rating of the supplier code, and the supplier name. Here I have some random names, okay, nothing special. In the D warehouse, we have the location, as we have Cape Town and Durban, the warehouse code, and the country. This means South Africa. And we have finally the fact tables, okay? In the fact tables, first we have the purchase orders. The purchase orders is a table where we can find some orders and the information regarding the order, that is the order date, when it was ordered, of course. Uh, we have the supplier code, we have the purchase order line ID, that is basically the same as the purchase order ID. However, sometimes we may have doubled. We may have doubled because we may have different part numbers. So for example, if because here we are detailing the part number column just one part number, but if I have more parts in this purchase order, I will see this doubled. Okay, this purchase order ID will be repeated in other rows as well. Okay, this may happen. And we have here the order quantity. This means that the part number 4.1, which is the 4.1, the rims. Yes, the rims. We have purchase 16, and this was the unit price. This was the warehouse where we are storing this. And when was the last purchase? We also have here, okay? Well, of course, this last purchase is in the time this was purchased, okay? This like this last purchase date may be more recent than this. This is in that day when we purchased this. This was actually the last purchase date. And we have the lead time. The lead time, if you don't know what is, it is the time in days, the period in days that's going to take for this order to be fulfilled, for us to receive, okay, this order. So basically we have here just 15 days for all of them. So that's it. And finally, the F transactions. This is the most important part, and I need to tell you one thing here. When we talk about inventory dashboards, inventory analysis overall, you may have two types of databases. You can find two types of databases. The first type of databases is when you have the transactions. Okay, what this means? It means that you have a list of records of transactions. This means that you know all the parts that are uh, arriving in the stock and the parts that you are withdrawing from the stock. So you have the detail for each transaction. Okay. And there are some systems, there are some companies that you will find another structure. Some companies will give you like the picture, like the status of the whole stock in that day. Okay, I have friends, I know a lot of people who work with these two scenarios. Okay, I know the two scenarios are very common. So now talking about from the data modeling perspective here, you gotta check what is the scenario in your company. Okay, sometimes your company is not exactly how I will demonstrate here, and this will require different DEX measures later. Okay, so the example that I'm going to bring here this week is with a detail by transaction. So here we are going to see a list of each transaction. We know the transaction type, for example, if it is a withdrawal or it's a receipt, or and also the quantity, the part number, which part number we are talking about, where we are talking about, the warehouse code, the transaction ID, the transaction date, and the unit price that this part costs. Okay, so that is one model. And sometimes in your company, you may have a different model, a different scenario. And that would be very different in terms of DEX. Okay. Personally, I have seen both of them, and I chose this one because I believe for demonstration, for learning, for giving you a most complete background, this will be a better example. Okay. Are you working with inventory right now? Let me know which type of databases you have in your company. Are you able to get the transaction level, or do you receive like the full picture of each day? In general, some systems are going to export this data for you for each day. Okay, like the picture, the status in the end of that day. All right. Okay. Well, this is our data set file. Here we have all the tables. Yeah. Okay. Interesting. Jens said that in his company he can extract both of them, both the transaction view and the picture view. Very interesting. Yeah, some people can access directly from the data warehouse, which is very nice. It's going to save you a lot of time as well. Perfect. So now let's start the show on Power BI. First, I will load here the data set on my Power BI in this new project. First, I need to close this file. Let me close it. Yeah, perfect. And here I will just select all the tables right away. And let me click on Transform Data. Okay, so let's just give let's take a look if all the formats here are correct. Like the date, a column is the date, all right. We have here, no, we don't, it's not all right. The month is slash year and the month number is slash year. It was not supposed to be a date. This is just a text. Okay, so let's replace the current because we want to show the data like this in a few visualizations on Power BI. Okay, so I want to make this just a text. Sometimes I want the number like this, 3/2024, okay? And the day, month, short, perfect. The D module, all right, the D module's parts. Here we have two empty columns. Let me remove them. You can just select the column, press delete key in your keyboard, and they are gone. And the D parts, well, everything right here, nothing wrong. The D supplier, it's also all right. The D warehouse, we have a situation. This row here was not promoted as a header. So I will click here, use first row as headers. Okay, so let's go for it. And everything all right. Now, oh, let me check one thing. Yeah, everything all right. The F purchase orders. Now let's check this. The order date is correct. The supplier code, part number, order quantity, and let me check the unity price paid. Yes, it's correct with decimals. Perfect. Warehouse code. Okay. Last purchase date is okay. And the lead time is fine as well. Okay. In the F transactions, we have here the transaction type, the quantity, and the part number. Look, here we have many rows with errors. And how can you enable this visualization on your Power BI, on your Power Query actually? You can open here the View tab, and I recommend you to enable the column quality so you can see this very easily. So let's scroll down a little bit to check. Look, we have a few rows with errors, like we couldn't convert to number. Yes, because this was not supposed to be a number, right? When we talk about the par number code, this is a text, and Power Query tried to convert this into a whole number. So this is wrong. Let's replace, and that's it. Now it's back to normal, 4.5, as it should be. Okay. And down below, we have others like BC002 and with the rest of the code for each bike. Okay, so that's it. Now all the queries, the tables are fine. I will just click on load. Okay, Perfect. Okay, so we have just loaded, we have all the tables here on Power BI, and uh, let me just do a quick check with you. Are you with me or not? Yes or no? Can we continue? Nothing new until this part, right? All the tables loaded. Perfect. Okay. So now, as you may remember, let's start the first pillar that is very important, that is the data model. So for this, I will open the model view on Power BI. And now let's check this. Oh, wow, it's too far away, one table from the other. Let me drag and drop them here. Well, this is the first time I see all the tables like this. They are far away. Okay, yeah, now it's better to visualize. All right, as you know, Power BI is very smart and it can identify the relationships for us, right? As you can see, all these lines, Power BI automatically has done it. So we now need to check if this is correct, and if we, in case we need to create another relationship, we also need to check this now. Okay, so first thing, I want to separate the uh, fact tables. The fact tables I want to leave here below. The dimension tables I will send to the top, and let's position the D suppliers and the D parts. Well, as we have here a relationship between the D parts and the D module, as you remember, I have just talked about this a few minutes ago, that we have this bridge table that is the D modules parts, okay, where we can explain which part belongs to each module. And well, in this case, as some parts can appear in many modules, you remember that the tires we share with many bicycles. Actually, all the bicycles use the same tires. So we needed to create this intermediary table that is the bridge table, because this would require, if we don't have this table in the middle, we would need to create a many to many relationship. What is this? Is when we have some parts that can belong to many different type of models at the same time. And this is not good for Power BI. Power BI doesn't work in the best way for this type of cardinality. Why? Because Power BI needs to find the granularity of one reference row to connect with the other table. And if we have this bunch of parts that can belong to many models at the same time, this is going to mess up with the engine to look for the values. This will create ambiguity in the calculations that can lead into wrong calculations. So you should never use many to many on Power BI unless you really know, unless you really understand what you are doing and the impact of this. If it's not going to mess up all the calculations and maybe create a bigger ambiguity in your model. Okay, so you got to be very cautious with this granularity. And we created this bridge table that is going to explain what are the parts that belong to each module. And in this bridge table, there's no problem of repeating the same part or the same model in the rows. Okay, there's no problem. So let me see. Let me show you. For example, for the model, no, for the part 4.1, we have here that four modules use the, no, I'm sorry, seven modules use the same part number, okay? And let's say that in a normal case scenario would be like this. You have just like this part, the BC01, 001, 1.1, that belongs only to the BC001. That would be like a normal scenario, right? But as we have this list of parts that may belong to many modules at the same time, we need this bridge table, okay? And well, let's leave them right here. Uh, and the D warehouse, let me position here. And here we have the D calendar. As you can see, the D calendar is all alone. There is no relationships, and we need to fix this because everything we do related to date in Power BI, every analysis, every visualization, every calculation, we want to use the D calendar as the central point of this. That's the best practice. That's the way we want to work, and that's the way Power BI knows how to work best. Okay. Yeah, let me see if you guys have questions. Did I see you change numerical data to text? So if so, I wish you could clarify the motive behind that. Yes, because in that column, we did not have only numbers. We also had text, and Power Query didn't load enough rows to know that. So I needed to change this manually. Okay. Can we have one too many relationships? That's the relationship you want to have. Okay, you can see here on in the other cases, all of them is always one too many. Okay, the one comes from the dimension side, and the many is in the fact side of the relationship. Okay. Why? Because usually in the dimension, we want to specify, we want to uh, determine the granularity of that thing. If we are talking about warehouse, I want to define what is a warehouse in this table. So if I open here, I have the warehouse WH001. That, okay, so I want to define what is this one data, I'm sorry, not data warehouse, but warehouse. I want to define what is this warehouse. Okay, and the same concept applies for the parts. For example, in each row of parts, I want to define, okay, this part BC001 1.1, what is it? It's the main tubes and joints, okay? That's the part I'm talking about. So you want to define this, and every time you want to have this one-to-many relationship, okay? Mine doesn't automatically relate the tables. Should I then relate them manually? Yes, maybe sometimes it could be turned off. Okay, you can turn on and turn off this in the file, options and settings, options. And then there is an option somewhere here, I don't remember exactly now, let me see, where you can enable and disable the let me see, query, report settings, filtering. It's somewhere here, data load. There, yeah, right here, data load. Auto detect new relationships after data is loaded. Maybe this is turned off in your Power BI. Okay, so you can make sure if this is correct. And also another required thing is Power BI will only create the relationship if it can find the same column name. For example, here the calendar is all alone because in the other tables, I don't have one column specifically called date. That's why. So for example, here I have order date, I have transaction date, I have last purchase date, but I don't have date, okay? Like specifically date. So that's why Power BI didn't connected this table to the others. So that's our job now. We need to do this. So I will place the D calendar here above. And the date, I will drag and drop to the order date first. Let's create this relationship to the F purchase orders. As you can see, as you may remember, in the purchase orders, we have two columns with dates. We have two columns. We have the order date and we have the last purchase date. Okay? What happens if you define one relationship? Yeah, this will be like the primary way that we can filter this table. I want to filter this table based on the order date. The order date is more important than the last purchase date. But I can also create another relationship from date to last purchase date. I drag and drop to the last purchase date, and I can create this relationship, but it will not be active. It will be inactive. Okay, so let's save. And now you can see I have two relationships, one with a continuous line and another one with a dotted line. Okay, the dotted line is connecting the last purchase date. And if I check the continuous line, is connecting the order date. Okay, and when we want to use the order, I'm sorry, the last purchase date that is not active, we have a DAX function to use it. It's just called use relationship. We call this function use relationship, and then we can make this calculation that we need. We're using DAX as if this connection would be active. Okay, so let's leave like this for now. Well, let me see some questions. Could it be possible that one part is allocated to a bike model and being incorrect? So BC001 has a part with BC002 2.1, or should we ignore this on this example? You are talking about if there is a possibility of a wrong list. Well, first of all, if you have data that you can't trust, the first thing you gotta do is to check the data, okay? For this data I am providing you here, this type of confusion will not happen. But if in your company this can happen, first you should not open Power BI. First, you need to go to the database, you need to talk with the guys from IT and correct the data first. Okay, that's there is no magic BI solution for wrong data like this. First, you gotta clean the house, make things better, and then after this, you can open Power BI. Okay. How does Power BI know how to create a relationship with another? It's going to identify the column names. If the column names are equal in the first place and have the structure that it can link, it will automatically find a way. So for example, it's going to check if this column repeats the value every time, or if it based on unique values. So if it's like unique values, like in the warehouse case, like this, we have unique values, right? So it's probably a relationship from the one side. This is the one side of the relationship. Even if the relationship is inactive, can we still perform calculations on these fields? Why make them inactive? Yes, Natasha, you can only have one active relationship at a time. So for this table of purchase orders that we have here, we can only have one connection, one relationship between purchase orders and the calendar, one active at a time. And in case we want to, let's say, analyze something related to the last purchase date, I will call this using DAX, using the use relationship. Okay, that's not hard. That's not, also, it's not simple, but it's not hard, I can tell you. I have other examples using this a lot. It's available here in my YouTube channel. You can open it in the live, in the live broadcast transmissions. There is a live class about human resources dashboard. And in the human resources dashboard, we do this a lot because we have a table with the date when we hired the employee, and we have the date when we terminated this. Let me check one thing. When we fire the employee, and we use this all the time to create the calculations. Okay. Yeah. All questions answered. Your questions were very good and totally related to the topic. Thanks for sharing. Very good. So yeah, we now have the calendar and the purchase orders, and we need the D calendar connected to the transactions. It's the transactions date. So let's make this one too many, the calendar too many transactions, and save. So now it's all good. Yeah. The model, we don't have the model specified here in the transaction. Okay, in the transaction, let's take a look closer. We have the detail by each part number, not by model. Okay. And in the F purchase order, we have also by each part number. It's not by each model. So that's why we have the model sitting here with only this connection to the model's parts. Okay? Yeah. Okay. If you have a many-to-many relationship, in the first place, you are not supposed to have. You are not supposed to have. If you have one, delete it. Okay. Uh, and in the second place, uh, to not have the many-to-many, you need to create this bridge table in general. Okay, that you're going to mix the both sides like this, like we mixed the D models and the parts. Okay, so you are not supposed to have a many-to-many. And well, that's it for now about the data model. And let's get back to the business case to remind you a little bit to where we are heading to. So the first thing, we need to have the overall picture, right, of the company, of the inventory. And in this case, we want to confirm the accuracy of the inventory level. And here we are talking about money. And we want to address the parts in stock as well. So let's go for it. I will start then the second pillar of this class, that is the DEX measures. First, you can see that we have all the tables loaded here in the right side, correct? And I want to create a new measures table. I will click here on enter data. Let's organize this. I will call this 0 measures, like this, okay? You don't need to input anything. Let's click on load. And now I add this new measures table right here. So here will be the place to add all the measures we have in our project. Good. So the first thing, let me bring a table, because in this table I will start dragging and dropping some columns, some values, just to check if we have the data here. So for example, I have the part numbers. So here I have all the part numbers with transactions. Okay, nice. And I have here the quantity. I have the quantity, the sum of quantity column. And here we have consolidated all the quantities of this par number that we had in the transactions. Okay, just to check, just to check. Good. And what else? We have a difference between the quantity, right? It could be the transaction type of receipt or withdrawal. So the same par number now has two rows. The same par number has two rows. And then this value is divided between the two rows. Okay, so let's start thinking about in terms of calculation, because if I want to calculate how many parts do I have in stock right now, what is your suggestion? What do you think on how we can calculate this? If I have this column of quantity, how can I sum all the parts that I have currently in my stock? Tell me here in the chat. If you have doubts, also please send me. If you have the bridge table, is it still comply with the star schema? Yes, because the bridge table is going to explain two dimensions, okay? It's not going to compromise the star schema, okay? And about the please change language on files to English Word. Let me check if it's not in English. Options. The regional settings. Yeah, it's in Portuguese. Thank you. This is automatic. Somehow, everything in my computer is in English, but somehow this insists to come back to Portuguese for the date. Thank you. Yeah. Okay, so we have here some suggestions. We have here the difference between receipt and withdrawal. Exactly. So we have to create these two measures, these two calculations. Receipt less withdrawal. Exactly. So in order to calculate this, I will create a new measure. Let's create a new measure. And I will call this quantity. I will abbreviate like this, quantity receipt. Yeah. And for this, I will use the calculate function, because we want to create this summarization, and we want to apply a filter into this summarization. Okay. And this the purpose of calculate is exactly this. So let's calculate the sum of the quantity column, Shift Enter to skip one row, and I want to call the transaction type column. And here I need to use quotes because it's a text. So let's type here receipt. It should be exactly how we have in the table, okay? And including case sensitive text. So here we have the quantity receipt. Okay, so now you can see that the first row here, we have 940. And for the second one, we also have the same value, although this is about a withdrawal. So now let's create a new measure. Let me copy this one and let's reuse. I will create a new measure that is going to be the withdrawal. And a very good hack for you. You can select, you know that we need to change just this text here and this text here. You can press Ctrl Shift L. First, you need to select the receipt word, Ctrl Shift L, and Power BI will select all the occurrences of this word alongside your code. Okay, all the occurrences in your code will be selected and you can change them at the same time. So I can type here withdraw. I press enter and it's made, it's ready. Okay, a very good productivity hack. And now we have here 713. And here we have 713. Also, we have the same numbers, the same values for the part number 4.2. So the values here will be the same. Okay. So yeah, we have done it. I chose to create this separately because in the future we will need to use the receipt and the withdrawal in other formulas as well. So it's going to be better to call just this measure separately and reuse, and it's going to be easier in the future. Okay? Yeah. So now we can create this new measure, finally, the new measure that is going to compute the quantity on hand, right? Quantity on hand. That is going to be the sum of the receipt plus, oh, actually minus withdrawal. Correct? Let me check your doubts. Subtract withdrawals from receipts, quantity on hand, yeah. Inventory, total receipt minus, yeah. Okay. Yeah, with this, we have the quantity on hand, and we have this total value here, about 15,935. Okay, so we have done this. For now, it's calculated, it's working well. But in the context of a Power BI report, a Power BI dashboard, things are going to get more interesting. How and why? Because when you are creating some analysis, let's suppose I want to analyze the data only of 2024, of only 2024. How can I do this? In general, as I believe everybody here would guess, I need to create a slicer, for example, right? I can create a slicer. I bring the calendar date table here. right? And you can play around with the slicer, correct? So let me define 2024 and to the end of 2024 only. Yeah, correct. Yeah. So do you think that this value now is correct? Do you think this value is correct? Because you know that now we have applied this filter here. And first we had was 17,000, around 17,000 of parts that we received, and we had 16,000 that we withdrawn from stock. So this is giving us this total of 784 parts in the stock. Do you guys think this number is correct? No, it's not double counting the rows. It's just showing that the rows here doubled because of the filter context, okay? But because we have the some rows that this value is actually not being calculated. If this is being calculated in the background, it's not double counting as it is here. Okay, don't worry. There is a difference between the row context that we have here and the whole total that is following the filter context. That is different from the row context. Okay, this is a more in-depth explanation that we have in the DAX Expert module in my course. I explained to you why this total that we are seeing here is not exactly the sum of every row that we have here. It's not, okay? It's not. The totals that we have here are calculated separately. It's not necessarily the sum of everything we see here, okay? Now I want, well, let me make my camera bigger here, my webcam. I want a round of applause to Luvo Toy. A round of applause to Luvo Toy. I'm not sure. Actually, I am pretty sure that I am pronouncing your name in the wrong way. I'm sorry for that, but this result here is not correct. Yeah, it's not correct. We in the on 31st of December of 2024, this was not our stock on hand. This was not. Why? Because inventory has a rolling balance. This means that we had some stock before 1st of January of 2024. I don't know if you remember, we have here data from 2022. So we have a few years of data before 2024. And we are not considering this balance, this running balance, if we do the DAX like we have done right here. So it's not working. Okay, this number is not correct. So we need to fix this. We need to fix this, and I'm here for that. Okay, very good. Thank you for the suggestion. Yeah, there are also minus balances in the stock because of the history of the stock. Yes, that's a good point as well, Jens. In some stocks, you may find negative balances. In our case here, I made sure that we didn't have. If you find any part with negative stock, it's an exception. But every analysis I could do, I didn't find any negative number. Okay, I did want to avoid this in in our case here. All right. But in some companies, you may find some negative balances. Yeah. Perfect. So let's fix this quantity on hand because this is not considering the balance that we had before. So let me start with the calculate function. And you can see that the calculate function is the most important on Power BI. And for this, we are going to use a function to remove this filter, okay? We want to remove this filter because we want to manipulate now this filter. We want to tell Power BI what is going to be the data range that it should consider for this calculation. And what is the data range? As we have this history before, we want to cancel this part right here, right? When we define the starting point, because we want to get the data all the way from the beginning, all the way from the beginning. So I'm going to use a very famous function called remove filters that is going to do exactly as the name suggests. So I'm going to call the dCalendar date. We want to remove this filter of date. And well, if I type enter right now, let's see the result. Let's see what's going to be the result. You can see this number is familiar. This number, you remember, that is the total. If we clean this slicer here, this was the total of the whole data set of all the years. That is exactly what it's doing now. It's deleting this filter of the beginning and the end. But we want to delete only the beginning. And we need to add another instruction here. We need to add the filter now that is going to be exactly in the dCalendar date because we want to define the when this is going to start. Oh, I'm sorry, when this is going to end because the starting point is from the beginning, all the way from the beginning. So we are going to limit when this is going to end. And how we can do this? We define the dCalendar date should be less or equal to the maximum of the dCalendar date as well. And why this works? Why this works? Why? Because in this case, what is going to be the maximum of the dCalendar date? What? I will just delete this real quick. No, let me actually create a new measure. I will create a new measure to show you what this max of date returns. Max of the dCalendar date. What this function will return here for us. Let me add this. Take a look. The max is exactly the last date that we have filtered. Okay, that's the last date. So we want to consider from the beginning. So we want to clean this and keep this. And that's the date we want to keep. If it was the opposite, I would change here instead of max, I would change to the minimum. You know, the minimum is the starting point, 1st of January. If I set here 1st of January 2023, now it becomes 1st of January 2023. Okay, so let me delete this measure. And we have here the quantity on hand. Let's use the max dCalendar date. And now we are using the last date here to define until when we should consider the date for the calculation. Okay, are you with me? Are you with me? Yes or no? Okay, so now we finally have the quantity on hand. We have this. And guys, the same logic is going to work for the cost. The same logic will work for the cost. So for the cost, we first need to define the cost from the parts that we purchase, the parts that we finally deliver to assembly, and we are going to use the same logic. So let's create them. Let's create. I will copy the quantity receipt. I will create a new measure. Okay. So here in the new measure, instead of quantity, let's call this cost and receipt so we can know that this is the material coming. And then here, what is going to be the difference? Here we are summing the quantity column, and in this case, we don't want to sum the quantity. We have which column for the cost? We have one column. Let me show you. I will go back to the table. F transactions. Let me change this short date. Okay, so we have here the unit price. Yeah, we have like 20, the unit price. But this, we also have a quantity. And we don't have a column here to consolidate the total between unit price and the quantity. This means that we need to multiply them. And the best practice for this, and guys, believe me, you will find this in all the databases, in most of the databases out there. You don't have a specific column with the total. You usually need to multiply the column of quantity and the cost. And also, this is better for storage purposes, okay? It's going to be, usually it's going to be uh, easier to process this instead of storing the data, okay? So we need to multiply them in the calculate. For this, as we want to multiply two columns in the table, we are going to use the sumx because the sumx is going to allow us to call which table we want to deal with. And here we can specify, we want to call the F transactions quantity column times the F transactions unity price. Okay, and now we have the cost receipt. Let me add this to our table. Let me add the decimal separator so we can have an idea of how much it is. Okay, now I need to do the same, but for withdrawal. So I will copy everything. I will create a new measure. I paste. And again, double click in the receipt, Control Shift L. Select all of them. This becomes withdrawal. If you want to escape the selection, you just click outside somewhere else, okay? And that's it. Hit enter. And now we have this new measure, cost withdrawal. And here we have, let me add the decimals, the thousand separator. Okay. And we now want to consolidate this for the total, correct? How we can call this? The cost inventory. How do you suggest? cost of inventory. We are going to use the same logic from the other, that is the cost quantity on hand. Let me use the same logic. But instead of the quantity, we want to use, instead of quantity, we want to use cost. So I will select quantity, Control Shift L, and I type cost. Okay, and the rest is the same thing. It doesn't change. Okay, now I add this, and here we have the other measure. Okay, let me see the filter. If we change here the slicer, it's filtering. All right. And now let's go to the chat. Let's check. Mr. Tall, no, it's not inventory. Is a rolling balance. So this is on hand is not correct. Well, I'm not sure if you are watching exactly the point where we are. Please be sure if you are watching this live. We may have answered this. Okay. Now we have just checked the cost and the level, the quantity that we have on hand. And we are free to start visualizing the costs, the levels by group, by par number, by model, and so on. Right? That's interesting. So let me check here the slide where we are. The first thing, confirm the accuracy of inventory level and the parts in stock. Okay, we have just done it. Thank you very much for the suggestions. And now we can proceed with the validation of cost of goods sold and the DIO. Okay, now let me check one thing with you. Let's suppose that, no, let's not suppose. Now we are going to start going more advanced, and these measures that I have demonstrated here, I wanted to do this step by step just to be more friendly, right, in the beginning. However, now I want to start going more advanced, okay, because this is going to require. And I will start using our AI tool, our generative AI tool for helping me. And now you will see how I work with AI, and I hope this can help you with that. Okay, so for those who are enrolled in my complete course, you have access to the Exodus GPT, which is a tool that we have in the course to help you learning DAX, learning data modeling, and so on, all the subjects regarding Power BI and Fabric. And here we can use, I will start a new chat using the O3 Mini. The O3 Mini model from OpenAI is very good at logic and coding. And yes, you have heard me before talking about AI will not give you all the correct measures, and it's a fact. However, let's use AI to save time. Okay, we're going to use this as a productivity tool to save time. So the purpose of this demonstration is on how you can use this correctly to leverage the results, save you time, and also give you better insights than you manually searching for information on Google or doing everything from your own mind. Okay, that's the thing we want. We want to double check, we want to validate the process as we develop the dashboard. And if you have taken the classes with me from my demonstration in the course, I have told you that for every Power BI interaction that I want with ChatGPT, I need to inform three things in the beginning of every interaction. I need to inform three things. What are these three things? The first one is list of tables, the list of tables and columns that we have in the project. Because if you just approach here ChatGPT and ask, hello, generate a COGS measure for me uh, for my project on Power BI. The answer that ChatGPT is going to give you, you can just take this answer and throw it in the garbage. Okay? This will not work because it doesn't know. Actually, in this case, it hasn't even. Yeah, it did give me a how can I say a DEX code, but these tables are not in my model, so it cannot guess, right? So just take this suggestion and throw it away. It's not going to work in your project. And we need to inform first these three things that I need to tell you. That the first thing is the list of tables and columns, so ChatGPT can understand, all right, what are the tables and the columns, the data types that you have available. The second is the list of relationships you have in your model. This later, ChatGPT will understand how all these tables and columns relate to each other. And the third part, you need to inform the list of measures that you already have in your project, okay? The list of measures. So in our case, we already have these 6 measures here. Yeah, let me delete this column. So we have these 6 measures that will be very useful for ChatGPT to help us to create the next measures, okay? So yeah, let's start by doing this. I will need to go to the DAX query view, and I want to, I want to add here the info dot relationships. No, let me start with the tables, columns. Yeah, columns. Let's start with the info dot columns. And this feature here, this DAX code in the DAX query view was created a few months ago. This is not something old, okay? This is very important, this is huge, and this facilitated this kind of information for us. So let's use it. And this is going to be very valuable for ChatGPT. So here we have the list of columns. So let's take a look. For example, we have the ID column, and each column belongs to one table ID. And then you can see that the table 12 probably is the D calendar, which has many rows, many columns here regarding the date. So it's all from the date column. And then we have here the full list. You can see that we have 67 rows. We have approximately 67 columns in our data model, okay? And then we have here many columns with more details about the columns themselves, like the data type, and other metadata. Okay, and just be sure that this is not going to leak any important information from your project. You are not inputting any data. This is metadata. This is not any data that is confidential from your company. This is just the explanation of the table of the model structure. Okay, there's nothing really confidential here. uh, if you have problems telling ChatGPT what are the column names of your data model, well, I don't know about it, but this is not confidential, okay? And this is not going to represent a risk. So I will copy the entire table. Click here, copy. And I will paste here. Consider this list of columns and tables. Yeah, and then I just paste, Control V, okay? And now consider this list of relationships. Now let's get the info.relationships. Now I have all the relationships here, just the metadata, okay? And I will copy the entire table. And this is going to tell ChatGPT which table, based on the table ID, you know, is related to one another. So this is the relationships. And now consider this list of measures. So let's get the point measures, info.measures. And I will also copy. You can see our 6 measures here, okay? Let's paste. You can see that inside the table, there is a column with the expression. So ChatGPT will know which DAX code we have used, okay? And well, in this case of our tool here, I believe there is not enough characters for pasting the third part. So yeah, as I can see, let me check. The last one is the 4389. Oh no, it's all good. It's correct. It's the last one. Yeah, I can hit enter. Uh, no, actually, before hitting enter, I will ask now. Can you, no, not can you, help me creating a COGS measure for my inventory analysis using this data set I have just sent you. Let's hit enter and let's see what we can get. Will this measure work perfect for the last transactions date of all items, transaction pipelines? Will this measure work perfect for the last transactions date? Yes. Yes, for all items, yes. Because we manipulated the filter only in the D calendar, only in the D calendar table. We haven't changed the filter of any other table. Does this O3 mini have limitation on uploading of the databases? Example, COGS table to use. Limitation on uploading of the databases? Well, the O3 mini has a standard, let's say, window of context. It's not the biggest window of context, but I believe it can handle really well this amount of data we are uploading, or that the data you will need to upload from your projects. Because you can also split this, and let's say if you have a too large data set, just filter the columns you need to use for that calculation, and it's going to save you a lot of tokens in the prompt, okay, if the size is a problem, but you can paste the values here without problem. So now let's check the answer from ChatGPT. Below is one way to define a COGS, the cost of goods sold measure using your data set. In your model, it looks like you track inventory transactions in a table, F transactions, and use a date table, the calendar, for time-based filtering. In your measures, you already have a cost withdrawal measure defined as. Yeah, exactly. For an inventory analysis, it is common to evaluate COGS as the cost associated with the withdrawal transactions, assuming these represent goods going out as sales. Yeah, that's true. So it's basically saying that the COGS is exactly the same as we calculated in the withdrawal measure, the cost withdrawal. Okay, so take a look. I have asked it to create this measure, and ChatGPT now could understand the whole picture. How interesting is that? Let me let me have a serious conversation with you now. Can you understand the power now? Because I asked it something, and ChatGPT already told me that, hey, hold on, you already have. Look, this is what you have. This is the COGS. I don't need to do this again for you. You already have. But understanding this whole picture, this context, now ChatGPT is giving me uh, some other tips, some other recommendations. So let's read the rest. For an inventory, yes, okay. So here is the thing. To make the measure time aware so that it responds to your time slicers, you can wrap the underlying calculation in calculate expression that removes the default date context and reapplies a filter up to the current date. Yeah. So basically this is what we have done. And this is both for the cost, and here it's summing using the same expression we have used. So it's saying that choose whichever approach fits best within your model design. If you already have cost receipt, yes, we have. Cost withdrawal, quantity receipt, yes, we have all of them. Then building COGS as a time-aware version of cost withdrawal might be the cleanest approach. Yeah, so it's basically recommending us to improve this for the time. You remember that in the cost withdrawal measure, let me show you cost withdrawal, we have the standard calculate with some X, and we filter this, right? That's the measure that we have. However, in the cost inventory, in the total, we have the time intelligence that is going to apply this only, not only, but until that moment that we are filtering, right? You remember that I changed here the filter. So let's say the last day of 2023. And this measure of cost withdrawal is not getting this context that we changed in the cost inventory and in the quantity on hand. You remember, this time intelligence is only present in these measures. So ChatGPT recommended, look, the same time intelligence you applied here with remove filters, manipulating the context of the date. Now, I would recommend you to calculate the COGS using the same approach. And it's wise to do that. It's a very good suggestion. Because this way, you remember, we had some costs before that. But in this case, I would change one thing still. I would create these COGS calculating only the last 12-month period. I would use only the last 12-month period, because as we have a very large range of dates from 2022 until 2025, I believe data from 2022, especially like right now, inflation is very high. Maybe this can distort the cost in the end. So let's adopt as a good practice to use the last 12 months for the COGS and for the following measures that we are going to create. Okay, so let's talk. Let's have this conversation with ChatGPT. I am thinking about defining the COGS only for the last 12 months based on the max slicer. What do you think? Do you also have some conversations like this with ChatGPT? I love doing that. I believe when you go deeper and creating this chain of thought, it's going to enable better results. Okay, guys, we have reached almost almost 1 hour 46 uh, minutes, and are you with me? I'm going to finish calculating the COGS and let's see if we can calculate the next measure, and it's going to be over for tonight. Okay, we're going to stop in these measures. Are you with me still? Are you awake? Yeah, good. Excellent. Many people online. Okay, so let's see what ChatGPT is saying. It's a common and useful approach to focus your COGS calculation on the last 12 months. Yeah, it's confirmed. By doing so, you can compare recent performance and trends without interference from earlier periods that may no longer be relevant. That's exactly what we want. And here it suggests some measures. Okay, here in this case, it's using the remove filters that you know very well. We are defining the calendar date less or equal to the max, and here we are defining when this starts, and it's using the date max calendar minus 12 months. That could be one approach. That could be one approach. I have, I also know another approach, but let's test this one. Let's test this one. I will create a new measure. This will be the COGS, cost of goods sold. And oh yeah, it already suggested the name. Very good. I just pasted and hit enter. It's saying that we have here syntax error. Okay, where is it? Line 2, offset 1. Where is it? Now, let me just copy and paste again. Let's see. Okay, we have here some syntax error in the line 3, cost withdrawal. I'm not finding what is wrong. The name is fine. Remove filters is fine. The end date. Let's check if this is the problem. Is it the name? No. Okay, where is this error coming from? Yeah, anyways, I will create a new measure from the beginning. Remove filters. Does it work? Yeah, it's in the beginning, the error doesn't make sense. Yeah, I will create just a new measure. Things that can happen in a live class. Cogs 12 last 12 months. Okay. And here we have the calculate of the, which measure was it? Cost withdrawal. And in this case, we want to remove filters from the D calendar date as we want to manipulate these filters. And the D calendar date should be before or equal to the maximum date, the calendar date. That's exactly what we have done in the other code. I type enter, it's all correct. That's really weird. Okay, and the rest of the expression, let me paste. When I add this, it causes an error. Yeah, anyway, I just think that this could be related to this eDate. I'm not familiar with this eDate call function like this. I usually use date add. I prefer to use date add to manipulate this. Returns the date that is indicated number of months before or after the start date. Yeah, this is a good option as well. Power BI has a lot of date intelligence functions, and you can have many different functions working in the same way. The difference is that some of them may have a better performance than the others. Okay? Yeah. And it could be something related to the characters. Yeah, I have just deleted the characters. I don't know if here from ChatGPT there was a hidden character. I don't know, but now it's working. Yeah, it was just a bug. Now it's working. Let's see what is the COGS of last 12 months. Okay. So now we are exactly uh, doing what we wanted. Right? We got this time window of 12 months that is going to consider the max calendar date that is defined right here. Okay, so we get now the last 12 months from the past based on this, using this measure. And this function is working fine. Yeah. Okay, very good. With this, we have just calculated the COGS, and you have seen that I believe for most of you who are at intermediate level, this could be an amazing time saver. What do you guys think? Did you like this example? And here, if you don't know what this function does, it's going to explain to you. So let's ask, for example, uh, what is better for performance? The eDate that it has used, or let me check the other function I have used here, the dates in period, the dates in period. Why minus 36? Why minus 36? Both functions are highly optimized indexed, so in most cases the performance difference is negligible, especially when working with a typical well-optimized date table. Yeah. So this is a scalar function. This returns a table of dates covering the specified period. And in summary, your goal is simply to compute a lower boundary for the 12-month period. Yeah. Using eDate is a clean and slightly simpler option. Okay. good point. The other the other measure I have, yeah, it's going to get a little bit more, uh, well, a little bit longer, but works perfectly in the same way. Yeah, so after all, e-date is a very good suggestion. Thank you very much, Mr. ChatGPT. I love you. Very nice. So we have just calculated the COGS, and well, the COGS, let me see, we had this in the slide. We needed to validate the COGS, and now we want to calculate the days inventory outstanding, the DIO, the famous DIO. Let me ask ChatGPT, can you explain to my students the DIO formula? First, let's check if ChatGPT is going to guess correctly which DIO we are talking about here. Yeah. Oh, the guy from Poland, I know this name is from Poland, I can't pronounce, about minus 365 days. Uh, you, in which case do you want to use minus 365 days? In our case here, uh, as we want the, yeah, instead of defining minus 12, I don't recommend doing the minus 365 because you may have some years with 366. This can mess up some calculations, I believe. I wouldn't do it. Okay. Oh, it's a woman. Thank you. All right. Uh, The DIO formula stands for Days Inventory Outstanding. It tells you on average how many days a business holds onto its inventory before selling it. So you can see that this is a very important KPI. This is a very important KPI. It's going to tell you on average. So here we're talking about calculating an average first. How many days a business holds onto its inventory before selling it. So we can have this idea of how much and how many inventory we are holding into our inventory. This is important because it's going to help the companies understand how efficiently they are managing their inventory. Lower numbers generally mean that inventory is turning over quickly. So that's is going to link another very important KPI, that is the turnover. We are going to calculate the turnover as well, uh, which is often a sign of efficient operations. So this is a very good thermometer of the operation. Okay, so the basic formula is the average inventory. First, we haven't calculated the average inventory yet, so we are going to calculate. And we need to divide this by the cost of goods sold. Does it ring a bell? Yes, we have the COGS. And we are going to multiply by the number of days. Okay? All right. And here in the DIO, we should also define the 12-month period. Okay? In order to have this more uh, this closer number, right? That is closer to the reality of today instead of the last 3 years, or maybe even more if you have a longer database. So let's limit this for the last 12 months. And here is a step-by-step explanation for your students. Average inventory. Okay, so it's explaining here the giving an example with numbers. So it's giving an example with, I'm not going to read all the text, okay? But it's very interesting that it has generated the example to become really friendly. And the cost of goods sold, okay, we already have calculated. The number of days. This is the period length in days. For annual calculations, it's typically 365 days or 360 days in some financial models. But for monthly or quarterly analysis, you would use the actual number of days. Okay. And how to interpret? If the IO is lower, it implies that inventory doesn't sit on the shelves very long before being sold, which is good. If the DIO is higher, it means that the inventory is sitting for more days before turning into sales. Yes. Uh, and I can tell you that our inventory is not taking a seat, it's sleeping. It's taking too long in the inventory in the warehouse. Okay. Yeah. Yeah. In the case, look, in the case of the DIO, it's suggesting to multiply by a fixed number of days, 365, or financial models with 360. Well, okay, but what I want from ChatGPT, what do I want? I want the solution. Very soon, Uh, mm, I want to retire. Let's leave ChatGPT with the measures. And okay, very nice. Create the measure of DIO for my data model. So let's leave this to ChatGPT. Let's analyze the solution and uh, let's test. I just used Copilot to ask similar question and the answer is spot on with added information I can use for a current project. Thanks. Amazing, amazing. Instant benefits. Okay, where is it? Yeah, below is one example. Okay, so it has suggested, it has mapped the measures that we already have. Okay, the DIO. Yeah, this measure for the last 12 months, and the first one doesn't consider the last 12 months. In this version, the measure fixes the analysis window to the 12-month period ending on the selected or maximum date. Yeah, that's the one we need. Yeah, you may choose either approach depending on whether you want. Yeah, this one is the one. So let me copy the DIO last 12 months and let's go for it. New measure. Let me delete this old measure. New measure. And wow, this one is longer. Let's check. So first, just to keep the standard, the DIO space last 12M. I like to follow a naming convention. So every time I have a last 12 months, I will type this using index and it's going to call this measure, this list of measures, okay? So we have the variable maximum, okay, minimum is going to get the e date, that's perfect. The period is going to be the date diff between the two dates, okay? And first is going to calculate the end inventory. This means how much was the inventory in the end of the period. So for calculating this, let me indent the code. It's calculating the cost of inventory and applying the filter all in the calendar date. It's cleaning the filter of date to get only to the maximum date. I have I have an intuition that this will not work as expected, but let's continue. Let's continue. var start inventory. Now it's doing the same process, but in the opposite side to get the starting inventory instead of the end. Okay. And then the average will be the start plus the end divided by 2. Okay. And then we have here, finally, the COGS. The COGS, we don't need the COGS to be calculated again. So let's give this optimization. We just call the COGS of the last 12 months. Okay, I just call this measure. It's already done. And then we have here the divide. The divide, that is actually the DIO formula, which is the average inventory divided by the COGS times the period in days. Okay, well, let's start with the easiest one. The period with days is just a date difference between maximum and minimum plus 1. Yeah, we should add the plus 1 because when you subtract dates, you need to consider the day you started. So yeah, it's correct. And the COGS is correct because we are just calling the measure that we already have. And the average inventory. This average inventory, I'm not 100% sure that will work. I would use a different approach. I would use the average X. I would use an average X. Look, I will get this code. I will get back to ChatGPT and I will say this. Look, I have done some improvements in the code, but, and I have a question actually, and I have a question. Why don't you use the average X to calculate the average inventory? Now let me paste the code we have created. I will submit. Using average X is a valid approach when you want to compute the average inventory over every day in the period. Yes, in many cases, however, the start-ending inventory approximation is preferred for a few reasons. Simplicity, just simplicity, data granularity. To use average X effectively, you usually need a measure that correctly computes the inventory cost for every day. Yes, I do want that. Performance in measure logic and design. That said, if your model provides reliable daily inventory figures, you would like more sensitivity to intra-period movements. Yeah, so let me summarize all this to you. Look, the measure, this is something that, guys, doesn't matter your area, doesn't matter what do you work with. I will simply open Excel and I will give you one demonstration. So basically what this formula of ChatGPT, what it's doing is getting the start inventory and the end inventory and divide by 2. Okay, so basically for simplicity it said that is doing this. So let's say that in the beginning I had 250, no, let's bring rounded numbers, 100, and in the end I had 200, right? That is exactly what it's doing, and it's summing both of them, right? And dividing this number by 2. So this is going to give me an average of 150. Yeah, but this is only like, let's say, 1st of January of 2022. And let's say that this is from 1st of uh, February of 2022. Yeah. And now let's say that if I have here from 1st of January all the way until 1st of February, and I do have this data, I do have all these data points. And let's say that here it was 100, now here it was 500, here was 0, here was 600. Let's say I have this wide range of variation. This simple measure, this simple mean will not get this. So it's really not very conclusive. The average is a very dangerous statistic. Okay, you cannot uh, blindly trust an average. Okay, you can never do that. It's going to hide a lot. You can only talk about an average with more certainty if you have the standard deviation, but we don't want to calculate standard deviation for the stock. Okay, we don't want to have this conversation here. We just want to calculate in the best way as we could as data analysts. I don't want to present the standard deviation of stock, the average of stock, to my boss. He doesn't give anything for this information. Okay, so this is a way more effective way. If we have all the data points, this average is going to be more accurate or not. What do you think? The average that I calculate using this first approach is better, or the average calculating the second approach? Which one is better? Tell me here. For those who are the brave survivors of this session, we are almost in the end, don't worry. I would prefer the second scenario, yes? So that's why I will ask ChatGPT to change this. All right. Uh, change my measure to use the average X from the dates of the D calendar. As I have this granularity per day. So take a look. We can have this conversation and improve the measure with ChatGPT, even if it doesn't suggest right away the best solution. So below it's the revised DAX. Okay, let's check. Minimum, maximum, period, average, inventory. Take a look at this average X dates between the calendar date. It's getting the minimum, the maximum, and just the average of this. Now it's calling the cogs, divide everything. So much simpler and more effective. Okay, now our measure is done. We have the DIO of 460 days. That's absurd. That's really high. Yeah. Let me double check this. From 1st of January, let me insert 1st of January of 2022 and to 31st. Let's go all the way to the end. 31st of March. 369. Okay, well, we had this monster number. What does it mean? Let's let's see. The DIO, let me get back here to the explanation. It's going to tell us how many days on average this inventory is sitting before we sell it. Okay, so this means that we have like 1 year of inventory. We have 1 year of inventory for this. That's a very big number, right? Of course, we can see the particular scenario for each part. We have some parts, for example, for the tubes, the main tubes and joints. Well, this value is higher. Well, surprises. Let me check another one. The brake levers, very high as well. Yeah, overall, our stock is very high. Well, okay, I accept this. But anyways, that's the DIO. And well, this, if you would guess all the structure, all the formulas, everything to create this measure, I believe you would take a while, right? And that's how we wanted to start creating. And we are going to get until this point in this class. That's all, okay? In the next class, we are going to continue to calculate the turnover. We are going to add the turnover, and we are going to start creating the ABC analysis. That is going to look like something like this. Let's see if we can finish this by tomorrow. The ABC analysis, where we have the slicers with the models with cells. For example, I select one bicycle here. We have all the classification with ABC, the ABC by part number. And here we have the three different colors with the detail. For example, we have three A items that represent 63% of value. Okay, so these three items here represent 63% of the value in stock. And we can also analyze this by group. This we can see that the wheel assemblies group is way bigger than the others. Okay, so we are going to prepare this analysis tomorrow. This you can also slice by the location, by a certain group of part numbers you can select, and this is going to get interesting. Okay. Yes, Marcin, the DIO, the smaller, the better. Exactly. The smaller, the better. Prof, will that Power BI live file will be available for us with source files for that webinar? Yes, for sure. You will have this on Hotmart when the three classes finish. I will upload the final file that I'm creating right here, right now. Okay. So I will upload this on Hotmart. And for everybody who wants to start practicing, I will add the link for the download to download the materials here in the description. And for tomorrow, there is also the link here in the description. Okay. I believe I will share the link in the groups, of course, as I always do. And you can check the link here in the description somehow if you are not in the group. Okay, and that's it for tonight. So until this point, we have calculated many important KPIs. We have explored more about the interactions with ChatGPT that we are going to use a lot tomorrow, because that's the new way of working, guys. If you are not working this way, you are just losing big time. Okay, you are just losing a lot of your time, and this is also helping you to improve, to I'm sure you are going to deliver better insights with this overall if you can speak with your data model with ChatGPT. That's the best co-pilot you could have ever. Okay, so let's leverage this in our project, in our class here. So I want to thank everybody who shared your thoughts here in the chat. It was very valuable. I loved the conversation. Thank you very much for the insights, for the suggestions. And tomorrow we have more. Okay, it's going to get more and more interesting. Thank you very much. And I wish you guys a good night. Okay, bye bye.